All right, my phone ran out of battery right before the end. I just want to make sure that you get this down. The electromagnetic force holds small objects together. Objects typically smaller than like a large hill. That amount of land or material is where gravity starts to take over and provides the force that holds everything together. The weak force allows radioactive decay, and the gravitational force holds really big objects together. I'm talking like moons, asteroids, planets, stars, galaxies, solar systems, clusters of galaxies. Those objects are held together by gravity. Objects on our usual scale and size, they're held together by the electromagnetic force. Now, very quickly, we see this word, electromagnetic, and we said this is where most of the forces that we know arise from. They ultimately come from an electromagnetic interaction. You see this first part, electric, electro, meaning electric, and then magnetic. Well, it turns out that back in the day, people thought that electric effects and magnetic effects, electric and magnetic forces, were separate. Then we realized that they are just two different manifestations, two different versions of the same underlying principle. So they start to think, if those two are really the same thing, just expressed differently in different situations, maybe you could say the same out of all of our forces. Maybe the strong, weak, gravitational, and electromagnetic force can all be combined in certain conditions into one underlying force, one equation, for instance, that would be called like a theory of everything, that describes every interaction in the universe. It's a really interesting thought. And so far we've had some good progress with it. We have actually been able to show that these strong electromagnetic and weak forces all arise from the same basic principle at certain conditions. Okay? In our current conditions, they act separately, but they really come from the same root conditions if you have the right setup for energy, temperature, other conditions like that. So we've managed to combine these, we still call them four fundamental forces, that's how they're expressed today. We've managed to combine these three. But gravity is a holdout. We haven't figured out how to integrate gravity with the others. If we ever can, we will have a theory of everything that can explain every phenomenon in the universe, every interaction. It sounds really cool. We're not sure we're going to get there. We're not sure that there is a way to integrate gravity with these three forces. But that doesn't stop scientists from trying. We're still trying to figure it out. It is an area of active research, and to be quite honest, it's pretty darn interesting. I don't pretend to understand almost any of it, but I know that that is what we're doing. That's all I've got for you for the nucleus.